The next topic is subquery. Subquery basically means a query within another query. When you have a subquery, you have an inner query and an outer query. The subquery can appear in a number of different places. The subquery can appear in the where clause, can appear in the from clause, can appear within the having clause. And there are basically two categories of subqueries. One is called non-correlated, the other is correlated. We are going to talk more about these two different types of subqueries in a later slide. Let's take a look at this example here. Show all customers who have placed an order. Select customer name from customer table where customer ID in, and then within the parentheses you have an inner query, which is select distinct customer ID from order table. What happens here is that you have an inner query and an outer query. So that's a subquery situation. In this particular case, what will happen is the database management system is going to execute the inner query first. Select distinct customer ID from order table. What it will do is it's going to give you a list of customer IDs in the order table. Whose customer IDs will be in the order table? Well, those customers who have placed the orders, their customer IDs will be in the order table. So then the DBMS is going to execute the out query. The outer query says select the customer name from customer table where the customer ID is in this list. It's going to go through all the customer IDs in the customer table and see if the customer ID is in this list. If it is, then it's going to print the name of the customer in the result. So as you can see here, well, what happens is the DBMS will first execute the inner query and then it will execute the outer query so that you will get a list that looks like this. So that's an example of the subquery. And in a lot of the cases, you can actually perform the query without using a subquery. So for example, let's say if you want to find out the name and address of the customer who placed the order 1008, you can do it in a couple of different ways. You can do select customer name, address from the customer table, the order table, where the order ID equal to 1008, and because we have two tables here, we need to join them. Customer table dot customer ID equal to order table dot customer ID. This is one way to solve the problem. Or you can use a subquery. You can do select customer name, address, okay, from the customer table where the customer ID equal to, then you do an inner query. You're going to select the customer ID from the order table where the order ID equal to 1008. So if you look at this subquery, what it does is it will select the customer ID from the order table where the order ID equal to 1008. So what it will give you is the customer ID of the customer who placed the order 1008. So it will give you a number like 101. And then you perform the outer query. Okay, select customer name, address from customer table where the customer ID equal to 101. So this is going to list the customer name and address for you. Both of these two queries will do exactly the same thing, right? However, they are processed differently by the database management system. So when should you use this query? When should you use this query? Well, if you analyze these two different queries, the good thing about this subquery, even though subquery will require more overhead in processing the query, the good thing about this subquery is that it doesn't require any join. In the query is only a query on order table. The outer query is only a query on the customer table. So it doesn't require any join. So that's a good thing. In case you have a very large customer table and a very large order table, but the subquery is actually going to be more efficient than the non-subquery. If these tables are small, if the customer table and order tables are small, then this one probably will work better because it's a small join, and subqueries usually have more overhead. But if the tables are large, then this is probably a better choice because you don't require any join. As we mentioned earlier, there are two types of subqueries. One is called the non-correlated subqueries, and the other is called correlated subqueries. Example we just saw, both of them were non-correlated subqueries, which means these queries do not depend on data from the outer query. And the inner query only gets executed once for the entire outer query. Because once you execute the inner query, what you will get is either an order number like this, or a list of order number like in the previous example. And then you will just execute the outer query to see if it matches the order number, or if the order number is within the list of the order number. So that's called a non-correlated subquery. There is also another category called a correlated subquery. They actually make use of data from the outer query, and they execute the inner query once for each row of the outer query. And they may use operators like exists or not exists. Let's take a look at an example here. Show all orders that include furniture finished in natural ash. So here, the outer query is select distinct order ID from order line table where exists. And then in the query, you select everything from the product table where the product ID equal to product ID in the order line table. It's matching the order ID with the order ID in the outer query, and the product finish equal to natural ash. What this is doing is, when the DBMS executes this correlated subquery, what it will do is, it will first execute the outer query. It will say select distinct order ID from order line table. So it finds the first order ID. Let's say the first order ID is 1001. And then it goes into the inner query and says select everything from the product table where the product ID equal to product ID of order 1001, and the product finish equal to natural ash. So it will first get the first order 1001, and the product ID associated with this 1001. Okay, so it executes the outer query first, and then it goes into the inner query, trying to select everything from the product table where the product ID equal to this product ID, and product finish equal to natural ash. Well, let's say if product 5 happens to have the finish cherry, well, then it doesn't meet this criteria. So what will happen is it will scratch this from the list. So then it goes to the next record in the outer query. Let's say order ID is 1002, and with product, let's say 3. And then it executes the inner query. Select everything from product ID where the product ID equal to this times 3, and the product finish equal to natural hash. And the product 3 happens to have the product finish natural hash, so it matches. Then what it will do is it will put this 1002 in the result. So after going through the whole list of order IDs here in the order line table, it will have a list of order IDs of orders which includes products with product finish that's natural hash. Union query is just putting the results of two different queries together. One thing about union query is you want to make sure that for these two different queries, they must have the same table structure. For example, they must both have, let's say, 5 columns, and each column must have the same data type as the corresponding column. Right, so that's the most important thing about writing the union query. So basically it's two select statements, and then you put the keyword union in the middle. In this example, the first select statement is going to give you the ID, name, and the order quantity of customers who order the most quantity of certain products. And the second query will give you the customer ID and the name of the customers who order the smallest quantity. And since both of these queries will give you 3 fields, the customer ID, customer name, and order the quantity. And so you can use the union keyword to put the results of these two queries together into one table. So that's basically what union query is.